Hey guys, so we're back with another problem, and with this problem we want to see whether for a linked list, so if this is our linked list and it's a singly linked list, and we want to see if we are able to retrieve the kth to the last element in just doing one pass, one traversal through this linked list. So let's say this is our linked list, and as before, we are not able to get the length of the linked list beforehand, so we don't know how many nodes are there in this linked list, so we can't do something like this that we are able to do in arrays. Like we can say array.length like minus the k, and then use this as the index to retrieve the data from the linked list. So we can't use this, so we have to implement our own method for retrieving this kth to the last element. So this is kth to last, right? And so what we are going to do, as you may guess, is that again we might use two pointers, one for the kth to the last element and the other one for the last element. So this is the last node basically, and so this is what we are going to do. So in order to better imagine this, again think of that narrow hallway analogy, and think that the hallway is dark, and you and inside each room is bright, so you can only see inside the rooms once you open them and see what's inside them. Now think that you have something like a selfie stick and there's a mirror attached to the end of it, and you are walking by this room, but at the same time this mirror allows you to see what's inside this room. So as soon as you detect that this room is the last room, you want to be able to tell me what's inside this room. And since this is a singular linked list, you are not able to go to this room and then come back to this room. You can't move in this direction. You can't move in this direction. So you have to use this selfie stick to know what's inside the room that's ahead of you. So we are going to use something like a selfie stick with a mirror attached to it, and this would be our runner node. Alright, so this is our runner node, and this is our current node. And as general, in all linked lists, the first node is called the head, and the last node is called the tail. And as soon as the runner node is equal to tail, which means the next node of the runner node is null, if the runner node is pointing to null, we want to stop and read the current node's data and return it as the k to the last element. So that's basically what we're going to do. So let's say if we want to retrieve the 3 to the last element, if k was equal to 3, like in this case, what we would want to do is to get that current node, attach one dot next to it to get to this node, and attach another dot next to it to get to this node. So for 3 to the last element, we are attaching 2 dot next properties to our current node. So imagine what would we have to do for k to the last element. So we basically have to attach k minus 1 dot next properties of fields. So with that, I think we're ready to roll. And if the dot next of these, so this would be our runner node, right? So this current node plus these two dot next, like nexts, sorry guys, would be our runner node. And if runner node dot next was no, so if that was no, then we would read the current node's data. So that would be in total 3 dot next fields. So let's implement this in code and see where we get. And for the runtime complexity of this, I think we are talking of, at worst case, if we have n elements in our linked list, and if we want to, and if we have n elements, then we have to go all the way to the last element, and that would give us O of n for runtime. So this algorithm would have O of n, since we're not able to retrieve k to the last element without actually moving our runner to the last element. So we have to pass all n nodes to get that k to the last element. Now, I'm going to comment out everything that we had from the previous example, and I'm going to make some room at the top. Actually, let me copy this linked list and have it over here. All right. Now, what I'm going to do is that I'm going to create a function. This time I'm going to do it over here. This function is going to be a public function of type static, and it's going to return to us an integer, which is the data inside these nodes. So if you recall, in our linked list node method, we said that the data is of type int. So we're going to return int. Sorry. We're going to return int, and we're going to call this about kth to last node, right? Kth to last. Now this will get the head node of our linked list, or whatever that we recognize is given to us as heads. As you recall, linked lists are of type are a recursive data structure. So like each node has a definition of the whole linked list. So we don't need to get the actual head. Whatever we are passing, we can consider as the real head for the linked list. So we are going to call this head, and then we are going to go to the body of our function, and I'm getting these for what? Cannot resolve head. We will resolve head. We will resolve head. I'm going to make this actually over here. So this is our head. Now over here, what we want to do is to create that runner node. We are going to get the head and the k. So I'm going to say we are going to get a byte of name k. So now what I'm going to do is to create that runner method first, runner node first. So it's of type. First, let's create that current node. So this is our current node, and for now, it's initialized to the head node, and this is our runner node, and its current node plus k minus 1 dot next fields. So how are we going to implement that? Do we need a while loop or a for loop? I think we can do it with a for loop, right? Yeah, we have to create a for loop for this. So let's do that. So for I of 0, I is less than k, and then actually I of 1, so we have to do one list. I plus plus, we want to have, and I'm going to set the scope of the runner node outside that for loop. So runner node, we're going to have runner node to be equal to at each iteration it would be the head, or yeah, let's initialize this to head as well for now, and then we are going to say runner node previous runner node dot next, right? So as long as we have iterations, we will set it to the next node. So if, for example, we wanted 1 to the last element, we will get the last element because I is 1. Or sorry, if we wanted the second to the last element, which is this one, we would only go to this loop one time, and we will only execute this loop for I of 1. If we wanted third to the last node, which is this case over here, we would execute this code 2 times. So for the I of 1 and I of 2, but not for I of 3. So this is how this for loop will work. Now, after doing this, I think we're ready to traverse through our linked list. So let's do that. We are going to create a while loop since we don't know the exact number of nodes in this loop, and we are going to say as long as runner.next is not null. So as soon as it is null, we want to remember the value of current node and get out of this function. So we are going to say as soon as runner node.next is equal to null, get out of this. And we want to iterate the current node and runner node. And so after we get out of this function, out of this loop, so we're not doing anything special here, so we're basically going to the next node and we're automatically storing the values there, and as soon as get this, we will get out of it. So I think we have access to the value of current node outside of here, so we can just return current node dot data. So I think that's all function. That's pretty much it. Let's call our method and see if it works. So I'm going to say kth to last. I'm actually going to create a var called result and call that kth to last method and pass it our node 1 and tell it what, like which element to the last I want. I'm going to say 3. 3 is an integer, so I will convert this to int, and I will probably need to convert this, but we'll see if it throws us an error. So I'm going to console log this. So what are we expecting to get back? So 1 to the last, sorry, 1 to the last? No. 1 to the last, 2 to the last, 3 to the last, right? So we are expecting to get this node. So we are expecting to get 5 in our console. So let's run this and see what number we get. We are getting 5. Let's run this with 4. So we should now get 3, right? Let's run this with 4 to the last element. And we are getting 3. And what happens if I give it 1 to the last element? We're getting 5. What happens if I give it 0? We will probably get some errors. Or no. So what happens if I give it a negative number? I will probably get the last element again. So that's kind of expected. We can throw in a case where it will give us an error if we give it a negative number for k, but that's optional. We essentially solved the problem, and the runtime complexity of this is OMN. Yeah, let me know if this was helpful, and I'll see you in the next video.